This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials, so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The most important plumbing testing rule for a general building contractor is not a pressure number. It is the order of work. Test first, get the inspection, get the approval, cover last. That order controls the rough phase. A wall can look ready for insulation or drywall, and a trench can look ready for backfill, but the plumbing is not ready to disappear merely because the installation appears complete. The California Plumbing Code requires plumbing, drainage, and venting systems to remain exposed until they have been tested, inspected, and approved by the authority having jurisdiction. A photograph does not replace that required inspection. A confident subcontractor does not replace it either. I want you to think of exposed piping as unfinished business. The pipe may be installed, supported, and capped, but the inspection step is still part of the work. If covering hides the joints or blocks access before approval, the authority having jurisdiction can require the work to be uncovered at the permit holder's expense. That can mean removing drywall, insulation, earth, or another covering so the system can actually be examined. For the general building contractor, this is a coordination decision. I am not teaching you how to operate a compressor, install test plugs, or adjust a gauge. I am teaching you when the specialty trade must be ready, what the test is supposed to demonstrate, what the inspector must be able to verify, and when the next trade may safely proceed. The rough inspection is a hold point in the schedule. A hold point means the project does not advance past that stage until the required condition is satisfied. In this case, the condition is not simply that the plumbing subcontractor says the system is done. The condition is that the required test is established, the work is accessible, the inspector can examine it, and approval has been given. Imagine a contractor who is trying to recover a lost day. The drywall crew is available now, but the plumbing inspection is scheduled for the next morning. The tempting move is to close one side of the wall and assume the remaining access will be enough. That shortcut creates a scheduling risk because the inspector, not the contractor, decides what access is adequate. If the concealed side contains joints or routing that cannot be verified, the covering may have to come back off. The better field decision is plain. Protect the inspection window. Keep the rough work visible. Keep the test active and stable. Make sure the approved construction documents are available. Make sure previously identified corrections are complete. Then release the following trade only after approval. Looking at this sequence table, I want you to notice that concealment is the final step, not the step that happens while the inspection is still pending. Rough installation comes first. The required test comes next. Inspector access and documents must be ready. Inspection and approval follow. Only then does covering or backfill proceed. That sequence also protects estimating and production. Premature cover can create removal labor, replacement material, re-inspection, and schedule disruption. I do not need to claim that every mistake produces the same cost. The supported point is simpler. If the work cannot be inspected because it was concealed too early, the permit holder can be required to uncover it. Good coordination avoids creating that problem in the first place. Drain, waste, and vent systems have two basic test paths in the California Plumbing Code, but the pipe material controls whether the air option is legally available. For a water test, the system must maintain at least a 10-foot head of water for no less than 15 minutes before inspection. The phrase 10-foot head describes the vertical column of water creating pressure on the system. The number to remember is not 10 PSI. It is a 10-foot head of water. For an air test, where the material is permitted to be tested with air, the system is brought to a uniform gauge pressure of 5 psi and held for no less than 15 minutes. Those two methods are easy to mix up because each uses a different kind of number. The water method is stated as vertical head. The air method is stated as gauge pressure. The shared duration is 15 minutes. I put the main testing values side by side because the distinctions matter. Drain, waste, and vent with water uses a 10-foot head for 15 minutes. Drain, waste, and vent with permitted air uses 5 PSI for 15 minutes. Potable water supply uses working water pressure or a 50 PSI air test held for 15 minutes. Standard fuel gas piping uses not less than 10 PSI and no less than 15 minutes. The central contrast is gravity piping versus pressure piping. Drain, waste, and vent piping normally carries discharge by gravity, so its test values are low. Potable water piping operates under continuous supply pressure, so the air test value is much higher. Remembering the system's normal job helps keep the numbers in the right place. A common mistake is to take the 50 PSI value from the water supply test and apply it to drain, waste, and vent piping. That is not a small mix-up. It places a high-pressure number onto a system with a different test rule, and it can become especially dangerous if rigid plastic piping is involved. Another mistake is to remember 5 PSI, but forget that the air test is not available for every material. The pressure and duration do not authorize an unsafe method. The material rule still controls. Potable hot and cold water supply systems must be proved tight using potable water at the working pressure of the system, or by an air test at 50 PSI. The test duration is no less than 15 minutes. From a supervision standpoint, I want you to separate the method from the result. The method may use working water pressure or the permitted air pressure. The result is that the system must hold without evidence of leakage for the required period. The general building contractor's job is to confirm that the chosen method is permitted for the installed material and that the test is ready for inspection. Fuel gas piping has a different baseline. Standard fuel gas piping is tested with air, carbon dioxide, or nitrogen at not less than 10 PSI. It must hold for a period satisfactory to the authority having jurisdiction, but never less than 15 minutes, with no perceptible drop in pressure. Oxygen is not an acceptable test medium. The gauge scale matters because the gauge is the inspector's window into the test. A gauge can show a number and still be too coarse to show a meaningful change. For required pressure tests of 10 PSI or less, the gauge must have increments of 0.10 PSI or less. That includes a 5 PSI drain, waste, and vent air test and the standard 10 PSI fuel gas test. For tests above 10 PSI and up to 100 PSI, the gauge must have increments of 1 PSI or less. That range includes the 50 PSI water supply air test. Think of the gauge as a ruler. A ruler marked only in large jumps cannot reliably show a small change. In the same way, a high-range gauge with wide spacing can make a low-pressure test look steady even when the needle has moved, by an amount the scale cannot clearly display. The code's increment rule makes the instrument appropriate to the pressure being observed. I am keeping this at the general building level. You do not need a lesson here on mechanical calibration. You do need the judgment to look at the test setup before the inspector arrives and recognize when the gauge scale does not match the required test. Suppose a gas test is set at 10 PSI, but the gauge is marked only in 5 PSI jumps. Even if the needle appears still, that scale is too coarse for the required low-pressure test. The right response is not to hope the inspector accepts it. The right response is to have the plumbing contractor provide a compliant gauge and establish a valid test before requesting approval. The most important safety distinction in this lesson is the difference between rigid plastic pipe and flexible plastic tubing when compressed air is involved. Rigid plastic plumbing, drainage, and vent piping must not be tested with air. That includes the common rigid plastic families used for drainage work. The hazard is not merely that a joint might leak. Compressed gas stores energy. If a rigid plastic pipe or fitting fails, the release can be explosive and can send broken fragments outward. Water behaves differently because it is nearly incompressible. When a water-filled system fails, pressure drops rapidly as water escapes. Compressed air can release stored energy much more violently. That physical difference is why an air test on rigid plastic is not just the wrong paperwork choice. It is a serious personnel hazard. The decision matrix makes the boundary clear. Rigid polyvinyl chloride, chlorinated polyvinyl chloride, and acrylonitrile butadiene styrene piping are not air test materials. Flexible tubing such as cross-linked polyethylene, polypropylene, and polyethylene of raised temperature may be air tested only when the manufacturer's installation instructions explicitly permit it. The word only carries the weight here. Flexible tubing does not receive a blanket approval for compressed air. The permission depends on the manufacturer's instructions for the actual product. If those instructions do not permit the method, or if they are not available to verify it, the general building contractor should not treat the exception as established. Imagine a plumbing subcontractor connecting a compressor to a rigid plastic drain system because filling the system with water feels slower. The general building response is immediate. Stop the proposed air test, clear people from the potential hazard area, and require a code-permitted test method. This is not interference with trade technique, it is site safety and code coordination. The memory connection is simple. Rigid plastic and compressed air do not belong together. Flexible tubing is a separate category, and the manufacturer controls whether the exception applies. Underground plumbing work adds a separate safety trigger. In a trench 4 feet or more in depth, employees must have a stairway, ladder, ramp, or another safe means of egress. That access must be located so an employee does not need more than 25 feet of lateral travel to reach it. The 4-foot number is easy to confuse with the separate 5-foot discussion commonly associated with trench protective systems. Keep the concepts apart. 4 feet triggers the egress rule addressed here. The worker needs a safe way out within the travel limit. Protective systems involve a separate set of excavation requirements and site conditions. A ladder placed somewhere in the trench is not automatically enough. The controlling question is the worker's travel distance. Every employee in the trench must be able to reach safe egress without traveling more than 25 feet laterally. This is a general building supervision issue because plumbing schedules often drive excavation access, inspection timing, and backfill. A test may be technically ready while the work area is not safe for employees or the inspector. Inspection readiness includes safe access, not just a pressurized pipe. Local authority adds one more layer. The California Plumbing Code establishes the statewide baseline, but a local jurisdiction may adopt more restrictive standards when the legal requirements for local amendments are met. In the field, that means the state number is not always the final number for a particular permit. I use a floor and ceiling memory aid. The state code gives the baseline floor. A valid local amendment can set a stricter enforceable ceiling for that jurisdiction. Before scheduling a test, the contractor should verify the applicable local requirement with the authority having jurisdiction, rather than assuming the statewide baseline is the only rule. Suppose a plumbing contractor prepares a fuel gas test using the statewide baseline, but the local authority has a valid, stricter requirement. Arguing from memory does not move the inspection forward. The practical decision is to verify the local amendment, coordinate the compliant test, and avoid calling for inspection until the actual jurisdictional requirement is satisfied. Inspection readiness is where all these rules come together. I want you to picture the general building contractor walking the job before the inspector arrives. The plumbing rough work is exposed. The correct test method is being used for the system and material. The pressure, or water head, matches the applicable requirement. The test has been established for the required duration. The gauge increments are fine enough for the pressure range. The inspector has safe access. The approved documents are available. Corrections from any prior visit are complete. The following trades have not covered the work. That walk is not specialty plumbing performance. It is coordination and quality control. If the test loses pressure or water level, the system is not ready for approval. The appropriate response is to have the responsible trade locate and correct the problem. Then re-establish the required test. If the gauge is wrong, replace the gauge through the responsible trade before inspection. If the material does not permit the proposed air test, change the method. If the work is covered, expose it as required before expecting approval. The key is to solve readiness problems before the inspector is standing on site. Calling for inspection while the test is incomplete, the plans are missing, or corrections remain unresolved can lead to failure, reinspection, and delay. The exact local fee process can vary, but the coordination principle does not. A contractor should call only when the work is genuinely ready. I also want you to notice how the systems connect. Testing is quality control. Concealment is sequencing. Gauge selection is verification. Plastic pipe restrictions and trench egress are safety. Local amendments are authority. One rough inspection touches all of those responsibilities at once. Here is the compact memory map. Cover last, plumbing stays exposed until it is tested, inspected, and approved. For drain, waste, and vent, remember 10-foot waterhead, or 5 PSI permitted air, with 15 minutes for either method. For potable water supply, remember working water pressure, or 50 PSI air, held for 15 minutes. For standard fuel gas piping, remember at least 10 PSI for at least 15 minutes, using an accepted test medium and a gauge fine enough to show small changes. For tests at 10 PSI or less, remember gauge increments of 0.10 PSI or less. For tests above 10 PSI through 100 PSI, remember increments of 1 PSI or less. For plastic, remember that rigid plastic piping is not air tested. Flexible tubing may use air only when the manufacturer's instructions explicitly permit it. For trench egress, remember 4 feet of depth and no more than 25 feet of lateral travel to safe access. And for authority, remember that the statewide code is the baseline, while a valid local amendment can be stricter. There is an audio practice quiz for this specific episode on plumbing testing and safety protocols. It is audio-based, so I read the questions aloud and you answer by tapping. I built it for people studying while driving, working, or moving through a busy day. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the material I covered. Subscribe so I can help you stay on track through every episode until you get your license. I know you are fitting this study time around real work and real responsibilities, and I am glad to be part of the process with you.